Welcome to the final part of VCAA Mathematics 2020 exam paper series. In this video, we will solve exam paper 2 section B, questions 5, which consists of 8 parts. In part A, both students were able to find the equation of the tangent. However, many students left out the brackets and some did not show appropriate steps. In part B, some students wrote down only one solution. In part C, the concept of the nature of tangent line was not obvious for many students. There are 3 subparts in part D. Common mistakes include writing the values within the interval in the wrong order, using incorrect brackets, and failing to use the results from previous parts. In part F, students did not expand the expression in brackets correctly. Only a small number of students attempted part G, but most were unable to write down the values of the parameter. Part H was attempted by only a very small number of students, and many missed the keyword restrictions in this part.
Hello, Math Champions! I'm Dr. Chen. If you want to improve your math skills and understanding so that you gain confidence, enjoy math more, and get better results, click subscribe and hit the notification button so that you don't miss anything.
Welcome to this VCAA Mathematics exam paper series. This is section B of 2020 exam 2 paper. There are total 5 extended response questions in section B. In this video, I will present you the 5th extended response question. In question 5, it states that the function f of x equals x cubed minus x. Here GA is the function representing the tangent to the graph of f of x at x equals a, and the point B0 is the x-intercept of the graph GA. There are total 8 parts in this question. Part A is to show that b equals 2a cubed over the result of 3a squared minus 1. Part B is to state the values of a for which b does not exist. Part C is to state the nature of the graph GA when b does not exist. There are 2 subparts in part D. Subpart 1 is to state all the values of a for which b equals 1.1. In subpart 2, the graph of f of x has an x-intercept at 1, 0. The question is to state the values of a for which b is greater than or equal to 1 but less than 1.1. As seen from the graph that the coordinate b0 is the horizontal axis-intercept of GA, we let GB be the function representing the tangent to the graph f of x at x equals b, as shown in the graph. Based on the above, part E is to find the values of a for which graphs of GA and GB are parallel and where b is not equal to a. Now, let the function p of x equals x cubed plus wx, where w is a real number. Part F is to show that p of negative x equals negative p of x for all w. A property of the graphs of p of x is that 2 distinct parallel tangents will always occur at coordinates t p of t and negative t p of negative t for all t is not equal to 0. Accordingly, part G is to find all values of w such that a tangent to the graph of p of x at the point t p of t for some t which is greater than 0 will have an x-intercept at negative t 0. In part H, according to the transformation in its matrix form, in the 2x2 transfer matrix, the diagonal element m and n are dilation factors in x and y axis respectively. Both m and n are non-zero real numbers. The elements in the 2 by 1 matrix representing horizontal and vertical translations respectively. The question in part H is to state if there's any restriction on the values of m, n, h, k, given that the image of p of x under the transformation always has the property that parallel tangents occur at x equals negative t and x equals t for all t not equal to 0. This is a long question, and we start with part A. Since f of x equals x cubed minus x, its derivative equals 3x squared minus 1. So f prime of a equals 3a squared minus 1, which gives the line equation at the point a f of a. So y minus a cubed plus a equals 3a squared minus 1, or in parentheses multiplies x minus a, or in parentheses. Hence, GA equals 3a squared minus 1. Substituting the coordinate b0 into the line equation gives b equals 2a cubed over the result of 3a squared minus 1. Since part B is to find the values of a for which b does not exist, according to part A, when 3a squared minus 1 equals 0, b does not exist. So when a equals plus or minus 1 over square root 3, b does not exist. Part C is to state the nature of the graph of GA when b does not exist. According to part A, we know GA equals 3a squared minus 1, and b equals 2a cubed over the result of 3a squared minus 1, which equals 2a cubed over GA. So when GA equals 0, or GA overlaps x-axis, b does not exist. Part D has two subparts. Subpart 1 requires to state all values of a for which b equals 1.1. Since b equals 2a cubed over the result of 3a squared minus 1, which equals 1.1, after rearrangement, we have the cubic equation 2a cubed minus 3.3 multiplies a squared plus 1.1 equals 0. Solving this cubic equation using CAS graphic calculator, we obtain a approximately equals negative 0.5052 or 1.3468. Based on function f of x has an intercept at 1, 0. Subpart 2 is to find the values of a for which b is greater than or equal to 1 but less than 1.1. Since b equals 2a cubed over the result of 3a squared minus 1, we need to solve the inequalities. 2a cubed over the result of 3a squared minus 1 is greater than or equal to 1 but less than 1.1. Hence, solving the inequalities using CAS graphic calculator again, we obtain the value range of a, which is greater than negative 0.5052 but less than or equal to negative 0.5, or greater than 0.8084 but less than 1.3468. Part E is to find the values of a for which GA is parallel to GB, where b exists and b is not equal to a. Since f prime of x equals 3x minus 1, f prime of a equals 3a squared minus 1, and f prime b equals 3b squared minus 1. Since GA is parallel to GB, which gives GA equals GB, so 3a squared minus 1 equal to 3b squared minus 1. Since b is not equal to a, solving this equation, we obtain a equals negative b. Now, a modified function p of x equals x cubed plus wx is introduced, where w is a real number. Part F is to show that p of x is an odd function, which implies p of negative x equals negative p of x. Since P of x equals x cubed plus wx. P of negative x equals negative x, or in parentheses cubed, plus w times negative x, which equals negative times x cubed plus wx, or in parentheses, which equals negative px. A property of the graph of P of x is that two distinct parallel tangents will always occur at coordinates t, P of t, and negative t, P of negative t, for all t not equal to 0. Based on that, part G is to find all the values of w, such that a tangent to the graph of P of x at t, P of t, for some t is greater than 0, will have an x-intercept at negative t0. Since p prime of t equals 3t squared plus w, the line equation becomes y minus p of t equals 3t squared plus w, or in parentheses, multiplies x minus t, or in parentheses. As p of t equals t cubed plus wt, the line equation is simplified to t cubed plus wt equals 2t multiplies 3t squared plus w, or in parentheses, which gives w equals negative 5t squared. As we know, t is not equal to 0, so w is less than 0. In part H, according to the transformation in its matrix form, the question is to state if there's any restriction on the values of m, n, h, k, given that the image of P of x under the transformation always has the property that parallel tangents occur at x equals negative t and x equals t for all t not equal to 0. If a function holding the property that parallel tangents occur at x equals negative t and x equals t for all t not equal to 0, it must be symmetric at original point. Since P of x is an odd function, which is symmetric at original point, the transformed function must inherit such a property. Since the dilation factors do not affect the symmetric property of a function, while both horizontal and vertical translations will affect the symmetric property by shifting its symmetric point. Hence, in order to maintain the parallel property, both horizontal and vertical translations must be 0. So h equals k equals 0. In the meantime, there is no restriction on both dilation factors m and n.
If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.